Okay, good morning. So let us continue the lesson. I think it is good to have a little bit working with Geogebra to see how it goes. Yesterday, do you remember we were talking about? Let me see how it works. Yeah. Okay, so I go to the 3D graphics for Geogebra. So I want to explore what we discussed yesterday. If you look back to your notes, the last problem we solved was finding an equation for a plane that passes through 2 points. What happened? Okay, passes through 2 points and then parallel to the y-axis. And we already got the equation, if you remember. So I have it here with me. So I want to point these, try to visualize it, yes. So we were supposed to find an equation for the plane that passes through these points. One point was A with coordinates 1, 2, and 0. That is 1 point. And if you see this blue dot is this one, you might say that, yes, you should expect that it would be on the ground level because the z-coordinate is 0. Yes, the z-coordinate is 0, so it lies here. And in this GeoGebra, I don't know why they don't label the coordinate axis. This is x-axis, this is y-axis, and this is the z-axis, and that is really a right-handed coordinate system. Yes. Okay, and then if I go to the next point, the next point was 0, 1, and minus 2, so it was B. So let me type it here. It was B. The point was 0, 1, and minus 2. Yes, so that is the other point. So if I start rotating this around, might be it is easier for you to see. No? Let me just go here. You see that point B lies somewhere below the ground, and it is expectable because the z-coordinate is 0. Yes. Okay, and then let me see if GeoGebra can do that. So the equation that I got for my plane was 2x. Let me punch it here. Just minus z minus 2 equals to 0. That was the plane we got. Yes. Okay, and then if you see, this plane really passes through these 2 points, yes, and it is parallel to the green axis, which is the y-axis. So that is, it's good to see in reality what's happening. So that is, so if I can get rid of this plane, might be it's better, isn't it? Show plane. So I hope that you agree with me that these 2 points exactly lie on that plane, yes, and from that perspective you see that this is actually parallel to the y-axis. So that was the way that we calculated. Is that clear? That's what actually we did. And I want to continue with the lesson of related to the planes a little bit more, so that we can, of course the lesson is more or less finished, but you need to explore things. There are many things that you need to know if you want to do it properly. Okay, so let me just pause recording. Okay, now let us actually continue the lesson. So do you remember we talked about equation of a plane? So if I write the standard equation of a plane, we learned that this is this equation, yes? Yeah. That was an equation. Can you describe it? Do you remember? Let us repeat. So what was this equation? This was an equation for the plane that passes through a point with coordinates x node, y node, and z node. That is some point, let us call it A, and is perpendicular to a vector n with components A, B, and C. Yes? In principle, I can rescale these numbers, because when I rescale these numbers, what happens is that I am making n longer or shorter, or I'm changing its direction, but it will remain perpendicular. Am I allowed to rescale these triple here? No, because if I rescale them, this point will go to somewhere else. Yeah, so be careful. Even though vectors and points are being represented by triples both, but when it comes to this vector, because of this idea, we can rescale this triple, and it doesn't affect the result, but we're not allowed to rescale this triple, because that's a different story. Yes. Okay, now let us do some algebra here. If I multiply this in, this becomes ax plus by plus cz. Yes? And then if I multiply this here and there and factor a minus sign out, I can move the negative signs to the right hand side. It becomes ax node plus by node plus cz node. Yes? And then what happens, this is a constant. These are given to you. These are also given to you. So if you calculate, it turns out to be a number. So let me call this number minus d, or just d. Yes, I think minus d is better here. Okay, I can call it d or minus d, but I call it minus d because I want to move it to the other side. Okay, so then what happens? This becomes ax plus by plus cz, and then I move it to the other side. It becomes d equals to 0. So this should look familiar for you. From now on, in 3 dimensions, any equation of this form for some choices of a, b, and c, and d represents a plane in a space. Yes? Of course, a, b, and c are not allowed to be 0 simultaneously, and that is reasonable, because if a, b, and c are simultaneously 0, then I will have the 0 vector, and it is meaningless to say that the 0 vector is perpendicular to the plane. So this means that usually, by the way, this is a good way to write that they are not simultaneously 0. Why is that? When I write a squared plus b squared plus c squared is not equal to 0, I am emphasizing that at least one of them is not 0. Yes? Because if this is equal to 0, this means that all of them should be 0, because this is non-negative, non-negative, non-negative. If the sum of the non-negative numbers is equal to 0, it happens if and only if each one of them is 0. So sometimes in the literature, instead of emphasizing it with English words that at least one of them is not 0, mathematically they write a squared plus b squared plus c squared is not equal to 0, which is equivalent to saying that at least one of them is not 0. Okay, so from now on, any equation of this form that you see, if you are working in a space, represents a plane. Is that clear? Okay, so for example, this equation, if I choose a to be 1, if I choose b to be 1, if I choose c to be 0 and d to be minus 1, let us see what happens. If I put it here, it becomes x plus y, and then z gone, and then I have minus 1 equals to 0. So x plus y is equal to 1. Okay? So don't get confused. X plus y equals to 1 in Math 2C was a line, because there we were working in 2 dimensions. But now, if we are working in 3 dimensions, x plus y equals to 1 is not just a line, it's a plane. Yes? Is that clear? So any equation that can be written in this form, this is a plane. Do you remember something like this we had for lines? Yes? Any line, any equation that can be written in this form in 2 dimensions is an equation for a line. Now, more or less similarly, any equation that can be written in this form in 3 dimensions, it represents a plane. Yes? And then something important. By looking at this equation, can you give me a normal vector to this? Because normal vectors are very important when it comes to planes. So it is very good. For example, do you remember, if I give you a plane, if I give you a line like this and I ask you to find the slope, you know how to do it, yes? You make y alone and then read the x coefficient on the right hand side, yes? That would be the slope. But for the planes, we do not have the notion of slopes, we have the notion of the normal vector. So this is important for us. By looking at the equation of the plane, you can read at least the components of one of the normal vectors. Yes? And what are they? These are the coefficients of x, y, and z. Yes, because you remember I started with this normal vector. These components appeared here. Yes? So whenever I give you an equation of a plane, first of all, by looking at the equation, you should recognize for yourself that is a plane. And if you need, you should be able to read the components of one of the normal vectors. How? By picking up these coefficients and put them in a triple. Yes? And of course, you can rescale it if you want to, but that's also another story. Any questions? Yes?
If one of the, like in this case,
If one of them on the other side, you have to move them in one side, to the one side, if you mean this.
Oh, that was not the question.
Okay.
If in this case you have x plus y is equal to 1.
Yes.
And z is not there because the...
No, when z is not there, it means c is 0.
Exactly. That was my point exactly. When z is not present, is c always 0?
Yes, exactly.
Okay.
Yeah, that's exactly the case. So if I give you this, and I ask you to find a normal vector for this, you would say the x coefficient is 1, the y coefficient is 1, the z coefficient is 0. It doesn't mean that z is not there. It means c is 0, because that's a different story. When you say z is not there, it means that I do not have the z-axis.
Oh, that was not...
Yeah, that's not the case. So this means that c is 0. Yes? That's exactly the case. So if I give you this, and because if I give you just this and I don't say to you that in which dimension, in how many dimensions I am working, you don't know if this is a line or if it's a plane. But now when I say that I am working in 3 dimensions, then this becomes a plane. And then if I ask you, can you present one of the normal vectors to this, then you take the coefficients and put them in a triple, that would be the normal vector. Yes? Is that clear? Very good. I want to redo the previous problem now completely algebraically. Okay, I do not recommend this, but I want you to learn this one as well. So do you remember the problem was this? The problem that I just showed on Geogebra, and we did it yesterday. That was this problem. We had a point, 2 points. A is given to be what? 1, 2, and 0. And then B is given to be 0, 1, and minus 2. And the plane is supposed to be parallel to the y-axis. We solved this using geometrical picture in mind, but now I want you to see this at least. You can solve the problem also algebraically. Yes. How? I would say that I am looking for an equation of a plane. Any plane has an equation of this form. So I would assume that the equation that I am looking for is this. Yes? And then I know that this plane is supposed to pass through this point. It gives me this fact that if I replace x, y, z coordinates with these, this becomes a true equality. So it becomes one equation. But remember, how many unknowns are there? Because if I want to specify my plane, if I want to specify the equation for my plane, I have to give you A, B, C, and D. Yes? In that case, I can claim that, okay, I did the job. But I know that this plane should pass through this point. So it means that if I replace x, y, z with these coordinates, it should satisfy. So this means that A plus 2B plus D is equal to 0. Yes? I replace x with 1, y with 2, z with 0. And then I have the same thing for this one. This is also supposed to be here. So what does it mean? I replace x with 0, I replace y with 1, so it becomes b. I replace a z with minus 2, and then I have this is equal to 0. So far I have 2 equations, but how many unknowns do I have in general? 4. Yes? Okay, there's also another piece of information that I want to use. In principle, how many pieces of information you need? You need 4 pieces because you have 4 unknowns. Okay, how can I use that fact that my plane is supposed to be parallel to the y-axis? We did it yesterday, yes? What is a normal vector here? Can you tell me? What is a normal vector? The coefficients of x, y, and z in a triple becomes a normal vector, yes? And if this plane is supposed to be parallel to the y-axis, then this normal vector, which is perpendicular to the plane, will also be perpendicular to the y-axis, yes? And the famous vector on the y-axis is 0, 1, and 0, yes? So this means that n dot j should be what? 0. And then you just dot product them. A times 0, so A times 0 is 0, B times 1 is B, C times 0 is 0. If I add them, it becomes B, and B is equal to 0. So I put B equals to 0 here. So I get this system. Yes, but this system apparently is not enough because I have 4 unknowns, A, B, C, and D, but I have only 3 equations. Okay, I can simplify this by putting B here and there, so this becomes an equation of this form. B0, B0, so this becomes A plus D, and then this becomes B plus D. Yes? But I will not be able to find A, B, and D, because A, B, and D are 3 unknowns, but I have only 2 equations. Yes? Do you want to say something?
You wrote the
Okay, thank you very much. So this B is 0, so it's minus 2C plus D. Thank you. But still, I have A, D, and C left, but I have 2 equations. So how can I solve the problem? In principle, you have 1 more equation. Yes?
They're equal to each other. So, and then you can remove...
No, I mean that don't try to solve it. Because I have only 2 equations, but how many unknowns are left for me? 3. So if you insist, you will not be able to find this exactly. There are infinitely many numbers for A, C, and D. Because you have, when you say that I have A, C, and D, it means I have 3 degrees of freedom. And when you have 1 constraint, it removes 1 degree of freedom. You have another constraint, it removes another degree of freedom, but 1 degree of freedom is left. So if I ask you how many solutions, how many numbers A, C, and D you can find and fit into these 2 equations simultaneously, you should say infinitely many. And that's not hard to see. I will try to show it to you. But there is another equation that is not... So let me just do this. So here you calculate A, it becomes minus D. And then you calculate here what happens. C becomes D divided by 2. Yes? Is that clear? So I move D and then I divide by 2. Minus 2, I get this one, that one. Okay, for example, if I put D equal to 0, A becomes 0, C becomes 0. So I get 0, 0, 0. So that is one answer for this system. For example, if I put D equals to 2, then A becomes minus 2, C becomes 1. If you don't believe, you can check these numbers here. A plus D is 0, that's correct. 2 times C with negative sign plus D is 0 is correct. So that's also a solution. So it is clear that whatever I choose for D, I will get something for A, I will get something for C, and that is a solution. That is clear that I will have infinitely many solutions, yes? But the point is that I have another equation here. Okay? And the equation is that I replace everything here. So instead of A, I put minus D times x. Instead of b, I put 0, because I know b. Instead of c, I put d over 2 z, and then I have d equals to 0. Yes? But the point is that I can get rid of d by just dividing by d. Yes? And then d cannot be 0. Because if b is 0, it means a and c are 0. And b is already 0. So then it means that this is not indeed a normal vector. So this is guaranteed that d is not 0. And then I am on the safe side to divide everything by d. So this becomes minus x. This is not relevant. This becomes 1/2 z. And this becomes 1 equals to 0. So that's the equation I get. If I want to confirm that this is the answer we got yesterday, let me multiply everything by minus 2. And then it becomes 2x minus z minus 2 equals to 0. And if you look back at your notes, either that was the equation we got or the negative of this. So this is algebraic way of solving the problem. I don't recommend that in these problems, but I want you to understand the connection between algebra and geometry here. Okay? Sometimes I will try to solve both problems, the problems using this algebraic method. Any questions here? To understand this better, let me solve that problem before we solve. Do you remember I asked you to find an equation for the plane that passes through 3 points? Yes? It might be a little bit time consuming, but I think it is worth it. It is worth it actually. So let me see if I have the numbers here. Yes. If you remember, in one of the examples that we solved yesterday, we found, actually, an equation for the plane that passes through these 3 points. 1, 1, 2, b, 3, minus 1, 2, and c, minus 2, 1, and 4. Yes? We solved this using the cross product of vectors. I still believe that that method is better because this is mainly geometry rather than algebra. But by the way, this is linear algebra with connection between geometry and algebra. Okay, so if you want to solve this problem using this algebraic method, so what do you say? You say that, okay, I need to find an equation for a plane, and I know that every plane has an equation of this form. Yes? So if I can find A, B, C, and D, then I am done. But I know that this point lies on this. Yes? What does it mean? It means that if you replace x, y, and z with these coordinates, this should satisfy. So this becomes 2z plus, 2. Don't get confused. I am putting numbers instead of x, y, and z. So this becomes 2c plus d equals to 0. Yes? And then I have this on this plane. So this means that it becomes 3a minus b plus 2c plus d equals to 0. And I have that point on the plane, so it gives me minus 2a plus b plus 4c plus d equals to 0. Yes? But the point is that this system has infinitely many solutions. Why? Because I have 4 unknowns, but I have only 3 constraints. So 1 degree of freedom will be left. How can I deal with that? The previous one, the system was easy, but here it's more involved because you have all 4 unknowns appearing in all equations. You shouldn't get confused. You should tell yourself that, okay, I will not be, of course, able to find the exact, all the values for A, B, and C, but I can write A, B, and C in terms of one of the other ones. It doesn't matter. You pretend that one of them is given to you, and then try to solve the system and answer and find the other unknowns in terms of that one unknown. For example, I can assume that D is a number given. Yes? So what I do, then I will get a system of 3 equations, but not in 4 unknowns, because I'm assuming that D is given, so there will be 3 unknowns. And then we have to solve this system. Okay? So how do you solve the system then? So for example, do you remember the first thing? So I mean you need to imagine it like this. Move D to the other side. And pretend that you know this number. Okay, that's it. And then how many unknowns are left for you to find? 3. And how many equations you have? 3. Yes? But you need to know, you will not be able to find a particular number for A, B, and C. What you will get is A, B, and C in terms of D. Yes? Okay, and that would be enough. Because if I find A, B, and C in terms of D, then I replace those values here, then I divide by D, and that D is removed. And I will be left, yes? So that's, what should I do? This is a Mat 2C problem. It's a system of 3 equations in 3 unknowns because I'm pretending that I know this value. And I don't know which way you want to do it. In this case, it is easy. If I add these two, do you remember what was the goal? The goal was to reduce the system into a system with 2 equations and 2 unknowns. But these numbers are very clear. So if I add these two, B is gone between these two, and I C left. If I add these two again, B is gone, A and C are left. That's good. So let us just do this here. If I add these two, it becomes 4A plus 4C is equal to minus 2D. Yes, and if I divide everything by 4, this becomes A plus C is equal to minus D over 2. That's one equation. If I add these two, it becomes A, B are gone, it becomes plus 6C is equal to minus 2D. And I put it here by multiplying it by minus sign, so it becomes minus A minus 6C is positive 2D. Yes? And now if I tell you what do I have, you tell me that you have a system of 2 equations and 2 unknowns because I'm pretending that D is given. And if I want to solve them, this becomes, I add them, it becomes minus 5C. If I add them, it becomes what? 3 over 2D. Yes? And if I want to find C, to make C alone, I divide by minus 5, so it becomes minus 3 over 10D. As now, this is the end of this problem, because I pretend that D is given, so C is found. Yes? And then what I do, I put it back in one of these equations. For example, the simpler one. A becomes A plus C, which is minus 3 over 10D is equal to D. I move it to the other side, so A becomes 3 over D plus 1 is 13 over 10, yes? D. That is A. And now that I have A and I have C, I put it in one of these simple equations. I would say that this one is simpler. Instead of A, I put what? 13, 10D instead of A. B is still not known, but C is this. If I multiply it by 10, it becomes 26 over 10. I intentionally write it like this. And then it becomes minus D. And then it becomes 39 over 10. Move it to the other side. So 39 over 10 minus 1 is 29 over 10. Yes?
C is 3 divided by 10, not 13. No, you used A for C.
Uh-huh. Here. This is correct or not?
No, when you
Is this correct?
yeah,
Okay.
that's correct.
And then I put it back here, yes?
No, when you put it back in the final equation, which is which you
Here?
No, the one you're doing right now.
Okay, so let me just, instead of A, I put 13 over 10.
No, like right now, the one you got B equals to 29 divided by 10.
Yes?
You used 13 divided by 10 to SC. But C is equal to 3 divided by 10, minus 3 divided by 10.
Aha, okay, I understand what you mean. So I should write minus 6, yes?
Yes.
Is that what you mean?
Yes.
But it should also be negative, yes? So instead of A, I put 13 over 10D. Instead of B, I put B. And then I multiply my C by 2. It becomes minus 6 over 10. Yeah, thank you very much. That's minus C over 10. And then what happens? This becomes 7 over 10 I move it to the other side. 7 over 10 minus 17 over 10, yes? But these numbers are not familiar for me from the previous one, yes? And my calculation is right or wrong? Do you see any flaws in my calculation? I hope the numbers that I have written here are exactly the numbers we used yesterday. Let me double check. 1, 1, 2, 3 minus 1, 2, minus 2, 1, 4. Apparently I have written this part correctly, and then this is also correct. When I add them, it becomes 4a plus 4c minus 2d. I divide by 4, that's correct. I add these two, it becomes a plus 6c is minus 2d. I multiply by minus sign and add them, it becomes minus 5c, 2 minus 1, 4. Yeah, that's correct. And then I divide, that's correct. And then I put it back in this equation, so it is a minus 3 over 10d. I move it to the other side, it is 13 over d. That's also correct. Then I put it here, 13 over 10d plus b, and 2 times c, it's minus 6 over 10, and that becomes 7. 7 over 10, it's minus 7 over 10 minus 1. So it's minus 17 over 10. So apparently it's correct, yes? Do you see any flaws?
Wait, what?
Yes. Okay, what is so mysterious? You are also confusing me. Is there something wrong? Yes?
Then A be minus 3 over 10d plus 5 over...
What?
I think you did minus d over 2, divided by 2 wrong on the A plus C.
Here?
No, and then when you went from there to the A plus C, I think you... Because don't think it's 13 divided by 10, did you? When you A minus...
No, let me just do it. So, do you agree with these equations or not?
Yeah.
Okay, and then I start adding them, so that's correct, so I double check. So when I add them, it becomes minus 5c is equal to 2 minus 1 half, it becomes 3 halves, yes?
Yep.
And then I divide by minus 5, it becomes minus 3 over 10, so that's correct. And then I put it here. So this becomes a, and then instead of c, I put minus 3 over 10d.
Oh, but on the top there,
on the right hand
these
side, it
divided
is
by
not d. This is what you mean.
Yeah.
Thank you. Yeah, because I remember these numbers are strange numbers. We didn't have these numbers. I remember Ruben said something else. Okay, so if I do that, what happens? It becomes 3 over 10 minus 1 half, which is 5 over 10. It's minus 2 over 10. So it's minus 1 over 5. Thank you. Minus 1 over 5d. Yes? Do you agree with this one now?
Yes.
Hopefully, yes? And now we go back here. Instead of a, I put minus 1 over 5d. Instead of b, I still don't know. And instead of c, I put this one. I multiply it by 2. It's minus 3 over 5d. And on the right-hand side, I still have minus d. And then I want to find b in terms of d. So this becomes minus 4 over 5. I move it, it becomes over 5. Minus that is minus 1 over 5. Yeah, confirm this one, please. Do you agree with this one or not? Yes? So that becomes minus 4 over 5. When I move it to the right, it becomes 4 over 5, but there is minus 1 here. So this becomes minus 1 over 5. Yes? So apparently it's correct, hopefully, but I want to check it with my answers. Okay, then I plug that back everything here. Instead of a, what do I write? I write minus 1 over 5 d times x. Instead of b, I write minus 1 over 5 dx. And instead of c, I put minus 3 over 10 z. And then instead of dz, I'm just confused today, I don't know why. So this is correct, and then I have plus t is equal to 0. Yes? So instead of A, I put minus 1 over 5D. Instead of B, I put minus 1 over 5D again. Instead of C, I put minus 3 over 10D. And instead of D, I just put D. Yes? I just divide everything by D because D is not 0. If D is 0, A, B, and C are also 0. But that's not possible. So D is not 0. So let us divide by D. I get rid of D. And I multiply everything by minus 10 to get rid of fractions. If I multiply by minus 10, it becomes 2x. This becomes positive 2y. And then this becomes positive 3z. And this becomes minus 10 equals to 0. I think this was the correct answer we had before. Yes. Anyway, but that's an algebraic way of solving. So you see, there are no geometry involved in this problem. Yes. So we just wrote an equation and then did algebra. But I think you agree with me the geometrical way was better here. Yes? At least the algebra was not that complicated. Any questions? So have it in the back of your head that you can solve these problems using algebra, but that's the price that you have to pay. But the point is this. The point is that you can look at the system using geometry. Okay, so now let us assume the other way around. I could have given you this system from the beginning. That's just a system. And if you want to investigate the number of solutions of this system, you can look at this problem, which is in algebra, using geometrical picture. You remember, exactly like that you had in Math 1C. If you want to solve a system of two equations in two unknowns, you can interpret each equation as being a line and try to visualize what happens for two lines in plane. Yes? That's more or less the same idea. Okay, now let us try to solve some problems and let me ask your opinion about that. I would prefer you to do it geometrically, but of course that's up to you if you want to do it algebraically as well. For example, I want to ask you one question. I give you two equations. This is a simple and good example. I give you this equation, 2x equals to y minus 3z. And I give you another equation, minus 3x plus 6y minus 1 equals to 0. I give you two equations. And now, first of all, let me ask you one question. What does this equation represent in space? What does it represent? Yes? Yeah?
A plane.
A plane. And what about this one? That's also a plane. Yes? Because you can just move them on one side. Both of them have this form. Now I want to show me that this plane is perpendicular to that plane. Yes? So for example, and then you know what is the meaning of planes being perpendicular. Let me also show you sometimes in tuition. So these two planes are perpendicular, so the angle between them is 90. Of course, you need to define the angle of the two planes. But do you think these two planes are also perpendicular or not? The plane of the table and this plane. They're also perpendicular, yes? That's honest. We want to show that these two planes are perpendicular. How can I show that? Yes?
You just take the coefficients and then do the dot product.
Why?
Because then you would get 0.
So, but you need to imagine why this is true, yes?
The normal vectors are also perpendicular.
Yes, if these two planes are supposed to be perpendicular, there is a normal plane to this plane. There is a normal vector here. There is also a normal vector here. If two planes are supposed to be perpendicular, it is clear that the normal vectors also should be perpendicular. Yes? So these kind of things you need to discover yourself. So what is the, for example, let me call the normal vector for the first component. What are these? Can you tell me what are these?
2 minus 1.
Minus 1, thank you.
And positive.
Positive 3. Yes? For this one, n2, why is this? Because you have to move it to the others, to one side. And then n2 is minus 3, 6, and 0. Yes? Can I rescale it by dividing by minus 3?
Sure.
In this problem, yes. Even though by rescaling I am changing this vector, but I'm not changing its direction, and what matters is just the direction. Okay, but let me dot product these two vectors. Then this 2 will be multiplied by that minus 3, it becomes minus 6, and minus 1 will be multiplied by that, and so they are not perpendicular, yes? Are they? Today I'm very confused. And then plus 0, so it's minus 12, yes? So, okay, let us ask this question. Are these planes perpendicular? The answer is no. Yes, because that's not 0. Am I right or not? Yes? So because the dot product is not 0, and then the planes are not perpendicular. But there is a good question, we will come to it. If they are not perpendicular, what is the angle between them? Okay? So in principle, we should be able to answer this question as well. But before that, let us try to do it here. Okay? Before that, we need to understand what is the meaning of the angle between two planes. Okay? So the angle between two planes is an angle between 0 and 90 degrees. That's by definition. Exactly. So I cannot draw them, it's hard to draw, but let us see two intersecting planes from above. If you do it from above, you will see something like this, if two planes are intersecting, yes? And then two angles are acute angles, and two obtuse angles, and two angles, so let me just make it more clear. So two angles are acute angles, and two angles are obtuse angles. By definition, the smaller angle is called the angle between two planes, exactly like lines, yes? Now my question is that's a good question, let us just do it here. So we discovered, let me see if I have done it right, yes. These two planes are not perpendicular, so the angle between them is not 90 according to this calculation. Then the question is okay, then what is the angle between two vectors? Between these two planes? Yes?
Can you divide by the length of both normal vectors? And then you have the cosine of the angle.
Okay, but cosine of the angle of what?
Cosine of the angle between the normal vectors.
Between the normal vectors. But is that angle is the same angle as the angle between two planes? This might be you are completely on the right track, but this is not trivial. You have to convince yourself that this is the case. Do you understand? What Ruben is saying is that instead of calculating the angle between the planes, let us calculate the angle between the normal vectors. And he is claiming that that angle is exactly the angle between two planes. Is that right? That is very close to the truth, but not 100%. Why is that? For example, you know that the angle between two vectors might be larger than 90. But according to this definition, the angle between two planes cannot be larger than 90. But these things you have to be careful. And the reason is clear. Because when I ask you to write a normal vector, you write it. So what you know is that this vector is definitely perpendicular to this, but you don't know in which direction. And that is important. Yes, let me try to explain this here properly. Okay, so for example, let us see from above these two intersecting planes. Yes? What I know that normal vector here, it might be this case that normal 1 is this vector and normal vector 2 is this vector. Yes? Agree? That is one scenario. If that is the case, the angle between, I want you to convince yourself that. So if this is the case and they are pointing in this direction, then I parallel transport it from here. And then I hope that you agree with me that this angle is exactly the angle between two vectors, between two planes. Yes? But we do not have any control on the tip of this vector. When I write the normal vector, I really don't know, is it pointing in that direction or the opposite direction? Yes, unless you really do that, and that is time consuming. So what I mean that it might be the case that n1 is in this direction when I write it, but n2 is in the other direction. So it might happen that this is n2. Yes, we don't know. And if this is n2, if I parallel transport it here, yes, and then calculate the angle between two vectors, I will get that angle, which is not this angle. Yes, is that clear? But it is related to that angle. What is that angle? 180 degrees minus that angle. Yes? So in principle, you can answer this question. Okay? But I want you to understand that you have to be a little bit careful. But in principle, what Ruben said is more or less completely correct. So instead of finding the angle between the planes, I can look at the angle between the vectors, but I have to be a little bit careful if something like this happens or not. Okay, but now that you have a better understanding, I want to wait for you and give me the final result. What is the angle between two vectors? Exactly. So use cosine inverse, sine inverse whenever you want. Don't put the numbers in calculator. Could you get the answer? Yes?
61 degrees.
I just will ask you to keep it exact because I don't know. But anyway, I don't have it here. We can calculate. So 61 degrees, you use the calculator, yes? Yeah. Okay. So let us see how you did it. So what is important, you see, I don't want you to memorize these things. Whenever you need to be able to visualize that. And that was very good that we were able to do it. So we found a connection between the angle of the planes and the angle between the vectors, normal vectors. But there is only one problem that we have to be careful, is that the angle between two vectors might be larger than 90, but this is not by definition acceptable if I say the angle between the two planes are larger than 90. Of course, I will take the other one. That's it. So what I do, I will find the angle between, and this is a very standard problem. I hope that in the exercises and quizzes, then now you know what to do. I have two vectors. I want to find the angle between two vectors. So what was the formula? So that was 1n1 dot n2 is equal to the norm of n1 times the norm of n2, and then the cosine of the angle between these two vectors. Yes. But n1 times dot n2, we did it. It's minus 12. So I put here minus 12. And then calculating the norms are easy. So this becomes the square root of these numbers are squared added. So it becomes 4 plus 1 plus 9. Multiplied the other one, 6. So you see here, it was easier if I rescale first, yes? But okay, I didn't do it, so let me just continue. So it's 9 and 36 and 0. And then I have cosine theta. So this becomes minus 12 is equal to 10, 14, a square root of 14, and a square root of 45. And that's cosine theta. And that's exactly what is happening. This one is an obtuse angle. Yes, because cosine theta turns out to be negative. It's minus 12 over, I don't know what that number is, so you just multiply them, yes? 450 and then 180, yes? So what's that? 36. Something like this. But now, if I calculate theta, I don't want you to put it in the calculator, of course you can, then it becomes cosine inverse of that number. But you need to realize, even without the calculator, that this is not acceptable for the angle between the planes because because that's an obtuse angle. So the answer to the problem, the angle between the planes, is what? If I call it alpha, it is 180. So let me write pi minus this angle. Yes? Yes? Yeah. So this is the crucial point. If it were positive, and that's the acceptable answer. If now that is negative, you have to remember that you have to write this pi. But this is understandable. Okay, let me give you another problem. That's also a good problem. Write an equation. This is good. So we try to solve this mostly from geometrical point of view. Okay. Determine an equation for the plane that passes through this point, 1, 2, and minus 1, and is perpendicular to these two planes, plane P with equation 2x y plus z minus 1 equals to 0. Another plane P prime with equation x plus y minus 3z plus 5 equals to 0. So remember, I want to write an equation for the plane that passes through this point and is simultaneously perpendicular to these two planes. Yes? First of all, can you tell me how is that possible that I have a plane that is perpendicular to two planes? Yes?
They should be parallel.
No, not necessarily. For the lines, you are right. By the way, let me ask you one question. Are these planes parallel or not? You should be able to answer that one as well. Are these two planes parallel? This is important, by the way. Might be I have forgotten to mention. Are these two planes parallel, and why? Whenever you want to answer something related to planes, usually it is better to reduce it to a question to normal vectors. Yes? So if two planes are parallel, what happens for the normal vectors? What happens?
The cross product is a zero vector.
Okay, no, before that, it means that the vectors are parallel.
Yeah.
If the planes are supposed to be parallel, the normal vectors should be parallel. Either you use that criterion, or you can say that one of them should be a multiple of the other one. It's easier in this case, but of course your method is also correct. So you read the normal vector here. Normal vector for plane P is what? 2, 1, and 1. The normal vector for plane P prime is what? 1, 1, and minus 3. Is one of them a multiple of the other one? No. Because if you want to make this one 2, you have to multiply by 2, but then of course this becomes 2, but this becomes 2 as well, which is not this case. So definitely this is not a multiple of that one. So definitely these two planes are not parallel. And if they are not parallel, either they are exactly the same, but they are not exactly the same because the equations are different. So, or they are parallel, or they are intersecting. And so this means that these two planes are intersecting. But still I am claiming write an equation for the plane that passes through this one as perpendicular to this one. How do you imagine that? Yes?
They're also perpendicular.
No. You can check that. This times that plus this times that plus this times that. In this case they are perpendicular. Yes? But not necessarily. Am I right? For example, if you open a book and put it here, these two planes are perpendicular to the table. Yes? Yes, you just open a book and put it like this. And the angle between them is even not 90 degrees. In this case, yes, they are perpendicular. But in general, no. Yes? So imagine that you have a book open and you put it here. The planes of those, the planes of the book are perpendicular to this one. That's the way that you have to imagine. Is that understandable? Okay. Now solve the problem. This is what you need to know in the course linear algebra at KTH, okay? And I see that some students have problems solving these problems because they don't listen to me, okay? And so whenever you want to write an equation of a plane, I told you yesterday how to think about it. I told you that when you see the question, write an equation for the plane, your brain needs to look for two pieces of information in the rest of the problem. What are those pieces of information I mentioned? Yes?
The normal vector and a point.
A normal vector and a point. Do I have any problems with a point? No, it's given directly. So then there's only one way for you to... So to try to find a vector that is perpendicular to the vector that you are supposed to write its equation. And this imagination that I told you, open the book and put it here, will really help you immediately. Yes? So try to learn. You will not be able to write an equation for the plane if you don't think in this way. You need one point, you need one normal vector. Any answers? Or at least any strategies? Do you have a strategy? Yes?
Yes, so those two planes, it will give normal vectors.
Yes.
And if you cross product them, the vector is going to be
Normal to the plane that I am. Is that understandable for everyone? I don't know how can I show it to you, but might be I can use my laptop. Yes. So assume that these are the planes. Yes. This is plane P, and this is plane P prime, and the plane that I am supposed to write is the plane of the whiteboard. Yes. I want to have the plane of the whiteboard perpendicular to these two planes simultaneously. This is something that you can imagine. Yes. So the angle between this plane and that plane is 90. The angle between this plane and that plane is 90. But that was a coincidence in this problem. The angle between these two are also 90. That is just a coincidence, but it doesn't matter that much. So let me just change it to this acute angle. There is a normal vector coming out here. Okay? When it is normal to this, it automatically becomes parallel to this. And there's another normal vector coming out from here that's also parallel to this one. If you cross product these two normal vectors, it gives you a vector which is perpendicular to these two vectors, but then automatically it becomes perpendicular to the plane. Is that understandable? So the thing that you need to imagine is just this. That, okay, I read the normal vector here, the normal vector here, but the normal vector of the plane that I am supposed to write is the cross product of these two normal vectors. That's the only thing that you need to do. But then I told you that you need to look for these two pieces of information. One point, which is directly given, and then try to construct a vector which is perpendicular to your plane. Yes, please.
But if these two wasn't perpendicular,
It
how
is-
would you get the angle between them to do the cross product?
you don't need
No, you don't need that.
Or
Because in the component form, you don't need that.
In component form. No.
Yes, that's the whole point of analytic doing things. So what we do, we read the component, the vectors here. So n sub p is equal to 2, 1, and 1, and then here n sub p prime is 1, 1, and minus 3. So what I need to do is to do the cross product. So n, the vector of the missing plane, is equal to np cross product np prime, and it doesn't matter in which order. Of course, the result will change, but the perpendicularity is not changed. So what I do, it's already there. So I cover this one. 1 times that is minus 3, minus 1 is minus 4. And the middle one is minus 6, minus 1, minus 7, but the middle one has an extra minus sign. And then finally you write 2 minus 1 is 1. Is that understandable for you? Yes?
Would you get the same result if you just took, or the same plane if you just took the plane perpendicular to one of the initial planes? Because I don't see, if a plane is perpendicular to the first plane, wouldn't it automatically be perpendicular to the other one?
No. No, I don't think so.
Because intuitively that's...
No, but so this example is just giving you that, but assume that this is a plane, yes, and this plane is perpendicular to that one. Consider another plane like this.
All right.
Is that understandable? That plane is I don't know. It's still make an angle with this one, but this one is not necessarily perpendicular to the other one. You have to force that one as well. Yes? Okay. And from algebraic point of view, if you ignore that one, then you will have 2 unknowns left for you, and then you cannot solve it. Yes. Good to ask these questions. Okay. Anyway, that is the normal vector of that one, and then I know how to solve it. How? The formula, I have it hopefully in my head. It becomes minus 4 x minus the x coordinate of the point given plus 7 y minus 2 and then plus 1 z minus minus 1 is equal to 0. I prefer to simplify it a little bit, so it becomes minus 4x plus 7y plus z, and then this becomes positive 4 minus 14 is minus 10 minus 9. Move it here, it's 9. So that is, hopefully, if I have done any mistakes, that would be the answer that we're supposed to get. Minus 4x plus 7y plus z minus 9. That's correct. But I mean that if this was a very simple problem, but if you do not want to think in this way, then it becomes you are making life hard for yourself, yes? So you need to think in this way. There is one more question I would rather to just express it right now, because then hopefully you understand how to write equation for planes. And there are one more session I want to spend on planes, and then I move to lines, and then we switch the topic, and let us see how it goes then, okay? So, determine an equation for the plane that passes through this point and is parallel to the y-axis and is perpendicular to this plane. Determine an equation for the plane that passes through this, parallel to the y-axis, but perpendicular to this plane. Yes, you want to write an equation for that plane. Let me tell you something else. So if that is, I told you the standard way is to find a point and a perpendicular vector. But we also learned, because you immediately understood, if I give you two parallel vectors, parallel means sometimes on the plane or sometimes parallel, yes, for vectors, then you can immediately find the normal vector by cross-producting them. So you can have these type of problems in your head. One, a point and a normal vector, which is the standard one. The other one, a point and two vectors that are on the plane or parallel to the plane. That's also easy, because what you need to do, just cross-product those parallel vectors. Yes? And that's the case here, isn't it? Your plane is supposed to be parallel to the y-axis, so it is parallel to the j vector. That's one vector being parallel. On the other hand, you don't need to imagine so hard. Your vector, your plane is supposed to be perpendicular to this vector. If my plane is perpendicular to this vector, the normal vector of this one automatically becomes parallel to the plane that I want. Yes? Now, do you have two vectors parallel to my plane? Yes. One of them is the j vector. The other one is the normal vector of this one. So forget about imagining it so hard. Just do it step by step. So what you need to do, take the normal vector, j vector, cross product, and that's it. So have these two prototype examples in mind. Either a point or a normal vector, or a point and two parallel vectors. Yes? So you don't need to imagine them simultaneously. It's hard. Just imagine them case by case. My plane is supposed to be parallel to the y-axis. It's not hard because I'm just thinking about the y-axis. So one parallel vector is the j vector. Forget about it now. And then you are supposed to make it perpendicular to this. I have my plane is perpendicular to this. So the normal vector of this becomes parallel to mine. So I have two parallel vectors. Whenever I have two parallel vectors, you don't need to think. Just cross product them. It becomes the normal vector. Is that understandable? So think in this way. Yes or no? Okay. And before doing that, you can solve it for the next time. I would recommend you try to see this on Geogebra again. Okay, so the previous problem A was what? 1, 2, and minus 1. That is my point. And then I had two planes. One was 2x plus y plus z minus 1 equals to 0. That's one plane. And the other plane that I had was x plus y, yes, minus 3z plus 5 equals to 0. Okay, so let me change the color of one of them so we are not confused. So the color of that one, let's make it, for example, this one. Okay, so if you want to see here what's happening, so I had one point, and let me just get rid of this show plane so you are not confused. So that is the situation that I have right now. Yes? I don't know. These are the two planes. And they are perpendicular. Do you see? They are really perpendicular to each other. Yes? Okay. But now, what do you remember what was the answer we got? The answer we got was this plane. Let us check it as well. So it is minus 4x plus 7y plus z minus 9 equal to 0. That is the plane we got. So which one is this? Let me change the color here as well to, for example, blue. Okay. So that was the plane that we got. And you see that is true. It is passing through A, you see, it is on the plane. And it is simultaneously perpendicular to both of them. So you see from this perspective, you see, can you feel that this purple plane is perpendicular to these planes? Yes? So that is what is happening. But you really don't need to imagine so hard. You just need to imagine it step by step. When I am thinking about the y-axis, I only concentrate on the y-axis, get some piece of information and forget it. And then I go to the next one and then try to extract another piece of information. Yes? Okay. Any questions? Thank you.